Okay, good afternoon. My name is Mariano Núñez Groche. I have a quite difficult surname, so Mariano is just okay. I am from Argentina. Quite a long journey to get here, but it was worth it, I guess. Today I'll be talking 50 minutes about some things in SAP security. Yes, this talk is called Attacking the Giants, Exploiting SAP Internals. So we are going to be reviewing some SAP internals and how they can be abused and how they can also be secured. Okay, so we're going to be describing SAP connectivity ways, okay, how SAP connects to our system, how there is some SAP interfaces quite quickly. Then we're going to be really working on what is a SAP RFC interface. We're going to describe what it is and what it is used for, how it can be, how it's implemented in SAP. Then we're going to describe the RFC library. Yes, that is the library that enables external systems to communicate with SAP systems through RFC. We're going to make to analyze the security review I did over this library. Yes, in March, I think it was. Then I'm going to tell you about Sapito. Okay, that is a tool that will allow you to perform this kind of audits and analyze the implementation and the security of SAP systems. We are going to describe which are the low-hanging fruits, okay, in implementations of RFC interfaces, some advanced attacks, and some conclusions and question and answers. Okay, SAP connectivity. The idea, I don't know how many of you have touched an SAP system, or I think that you all know that there are like big monsters, right, running in a company, processing all the business information, related data, really critical information. Yes, I think that you all know that the data that is processed and stored in a SAP system is really critical for the business. So obviously security is highly critical. SAP has also to integrate into a company. Okay, it has to communicate with other systems. It cannot be running just standalone without any kind of connections. So SAP has really made a good effort and developed a lot of interfaces to connect with our system and from our systems to SAP. So some of them are based on open standards, okay, like HTTP, FTP, XML, web services, SOAP, etc. But you have also some proprietary interfaces, okay, like LEA, ADI, and RFC, okay, that is one that we're going to be focusing today. This one. Okay, when I start researching on something, I really like to know a bit of the background, okay, on what I'm researching. So the idea is that in the beginning, in the 80s, SAP implemented a protocol that is called IBM CPIC. And it's a protocol mainly to perform data transfers. It's just plain data transfer between systems. It was okay for a while, but then SAP realized that they needed more power. Okay, they needed to be able to call functions on remote servers. So this interface was born, the SAP Remote Function Call. Yes, that is what RFC means. And okay, it's based on CPIC, so it's like an upper layer of CPIC. And the important thing here is that the RFC today is a key component of SAP implementations in an organization. Okay, we'll see why. Okay, the idea is that you may have different systems. Okay, they may be just the same company or with other providers or whatever, so suppliers or any kind of clients. So you'll have a system, okay, with a central instance for sure that is going to be running the core services. And you may also have different dialogue, what are called dialogue instances, just to provide more service to the users. Okay, the idea is that connections between different systems is done through RFC. The connection with the end user, okay, who is running SAP GUI, that is the graphical interface to access SAP, is mainly done by a protocol called Dialog or Diag, but it's also can be done through RFC, some parts of the communication. And the more important thing for us is that also communication with external systems, okay, that may be or maybe not SAP related, is also done using this protocol, okay? Also connecting with external servers or with external clients, okay? So the idea is that RFC is used everywhere and it's really, highly used in SAP implementations. Okay, RFC, function units in SAP are called function models, okay? So for a function model to be able to call by using RFC remotely, it must be flagged. It's like a property of the function. Yes, it's remote enable. If it is remote enable, it is able to be called RFC, discarding some authorization checks, but I mean, it must be remote enabled. Okay, this is how an ABAP call to a remote function looks like. You have a call function and the function name. Yes, in this case is Sita Casket Money. A destination keyword which specifies the destination that we are going to analyze now. And you can specify exporting parameters, okay, which information you are sending to the function, like function arguments. They're going to describe the importing parameters, yes, return values from the function. Also, you can send and receive tables, yes, like more big structured data. And you can also process some exceptions that happen in the client, in the server, sorry. So this is like a regular function call structure. So what's this destination Pro2 about? Okay, the idea is that Pro2 is really an index key into a table that is called the RFC desk table, which is maintained through a transaction. It's called SM59. And the idea is that Pro2, I mean that keyword in the table specifies all the connection parameters. Okay, so there's going to be this table that has, okay, Pro2 is going to connect to this system using maybe this user, to this client, etc. Okay, so the call is just made to using the index key, but all the information, the really connection parameters, are stored in that table. Okay, a thing that I didn't tell you before is that a connection between systems, okay, between SAP and other systems, and maybe they're SRP or not, is done through a special service that is called the gateway service. We are going to be looking at it a lot today. It is, well, and it does just that. It handles the communication between SAP systems themselves and between SAP system and external systems. It is logical, I mean, it's the same TCP port, but it provides different services. You have a gateway reader, okay, that interacts with TCP IP partners. A gateway reader work process, that this one is mainly used for mainframe communication using the LU62 protocol. And you have also the gateway monitor, okay, that's the one we are going to be analyzing today. But some part of analysis. The idea is that it enables you to perform administration of the gateway service. Okay. Okay, so the connection between SAP and external systems can, I mean, the SAP can take one of two roles. Okay, it can behave as a server or as a client. In the first, I mean, it's just a really stupid diagram, but the external system is a client program, running a client program, who sends the values to the gateway, who then sends to the application server, to a function model, does the processing, and sends the result back through the gateway. And it can also work on I mean, you can connect to an external server, so the SAP system is working as a client, who sends the call to the gateway, who forwards it to the system, and so on. So SAP, I mean, you can connect also with the external clients or with the external servers. There are two ways of connecting with external servers. Okay, external servers can work in one of two modes. They can work in starting mode, yes, where the application server, but really the gateway is the one that starts them remotely on demand. Okay, so the application server is going to tell the gateway, okay, listen, I want to communicate with this program, so I want you to run this program in this host. The main problem I found here is that despite that you are able to specify which program you want to run in which host, is that remember that we can, as external clients, I mean, the application server is going to tell the gateway to run a program in a remote host, but we can also tell the gateway the same thing. Okay. The main issue here, or one of the main issues, is that this connection to a remote host, okay, how the gateway starts a remote program or a remote host, it is mainly done by RSH or Deepsec, okay, they are quite insecure, we all know that. I think in newer versions they provide SSH support, which is quite more secure. But anyway, there is a trust relationship there, so if you gain access to the gateway, you may get access to another system. And the important thing here is that the external server is closed after operation. Okay, so the gateway starts it, he sends an RFC call, the processor, the RFC server does the processing, and it's closed after operation. The other way is to run a registered server, okay, a registered external server. This is quite a different approach, yes, in which the external server connects itself at the gateway and says, okay, here I am, I want to be registered in your service, and my ID is this one, okay? It provides itself his ID. That's called program ID or TP name, it's the same. And it's not closed, it's like keep working like a service, yes? So it's always available for receiving RFC calls from the gateway. Okay, so I was talking about connecting with external clients or external servers. That can maybe be your own custom, application. But how do you have to develop this application to connect with SAP? Well, the RFC library is the answer to that. Okay. This is like a nice quote that I read when I was deciding which subject to research on SAP, and it was like quite appealing. I mean, it's something that you can't resist. RFC library is the most commonly used and installed component of existing SAP software. Okay, so vulnerabilities are going to be the most commonly used one and more installed. Okay, really, in fact, this is an API released by SAP to allow the development of these external clients and servers. Okay, so you have just to develop your C program and link this library with these special functions, and you are going to be able to talk RFC with an SAP server. It's available for all SAP supported platforms, so you can find this library in many distributions. And there is also an upper layer. Okay, you can develop your C program using this library, but SAP also provides an upper layer, yes, wrappers again over this library for Java and for .NET. So you can also develop this kind of applications that connect through RFC. And one of the important things here is that deliver with examples. Yes, just for you to learn, but also we are going to see which are the consequences of these examples. Okay, this is just a brief look of how an external server looks like. The idea is that this is you developing your external server, okay? First of all, you have to install which functions you are going to provide to a client. So this is done by the RFC install function, C function, where you specify the function name that you are going to use for that function, a function pointer, okay, that's a regular C function pointer, and you can specify the documentation string. Then you will enter like a loop for listening and dispatching function calls. So that is that when an RFC call is received by your server, it's going to be checking which functions you have defined. If it finds a function with that function name, it's going to be calling the associated function pointer, okay? That's the idea. This is quite easy, quite straight. There are three functions that are installed by default in every external server, okay, that are documented by SAP. That are the last three ones, is RFC docu, RFC ping, and RFC system info. Okay, that's quite a big introduction. So now we're going to go to the subject, really, that is the security review, which are the results of what I was working on the last year, analyzing this library, this implementation. First of all, you should know, the first thing that you will do when analyzing a proprietary protocol surely is to set up a TCP dump or whatever to analyze some traffic. So that's what I did also. And the first thing you realize is that clear text, all the information is being transmitted in clear text by default. SAP is quite aware of this, so they have developed this SNC interface that enables you to encrypt traffic, really. So if you are wanting to protect this traffic, RFC traffic, you should implement SNC. So what can you get? Analyzing a traffic dump or just sitting and analyze traffic from an RFC communication. You can get load information, okay? You can get a client. I don't know if all of you know, but the most usual way to access, to authenticate against the SAP system is to specify a client that is a 3-digit number, a user ID, and a password. Okay, those are the required credentials. So you will be able to get that. You will be able to get which function name is being called, which function parameters are being sent. Remember that we're talking about SAP traffic. Okay, so it really may contain sensitive information. Like payment orders or customer information, whatever. So you should really use SNC. And here's an example of a traffic dump. Here then in yellow you can see some information. You can see the user that is being used, it's called BC user. The client is that 000. There's the default client, the most important one. There is that 640 is the version of the library of one of the partners. Then the function name, then the parameter name, and then the parameter content. Okay, so you are getting all of it, looking at the traffic. But, okay, I told you that the data was clear text, and you can get all the credentials. But if we go back here, I mean, credentials related, you only see the username and the client. Okay, there is like no clue for the password. So I say, okay, maybe the password is being transferred encrypted or somehow. It has to be transferred, so it must be there. I discovered that the password was being obfuscated. Okay, there was some obfuscation procedure being involved. I really realized that it was a highly complex algorithm that is being used. This was like XOR, a fixed-OR operation. So this is just the key that is being used. So now if you analyze traffic, RFC traffic, you can just get which is the password that is being used. Okay, beyond the show, you cannot really blame SAP for this because they are telling you that it's clear text. So it's like blaming Telnet because it's clear text. Okay, just use SSH. Okay, just if you want security, use SNC. SAP provides it. So it's just, but okay, with this information, you can now obtain really password that is being used in the connection. Okay, so the next thing I did after analyzing traffic was, okay, there are some default install functions. So any server that you're going to develop is going, maybe you want a server, an external server, to provide only one function, but okay, it's going to be also having these 3 default functions that I mentioned here. So I started analyzing them, okay, just to see what they did, what they do, and how to use them. I don't know why that went blank. Okay, the first one is RFC docu. It's quite naive. It just allows you to retrieve the documentation that you can have configured for each function that you have installed. It may allows you to discover which functions are installed, okay, which functions that you yourself develop are available. But it's only available on external servers, okay, it's not in application servers. The next one is RFC ping. It's just quite descriptive. It's a ping over RFC, so you are able to use it to check the availability of remote RFC servers. By default, there is no need to specify logon data, so you can check anonymously to see if an SAP system is up, because it's available in external servers, but also in application servers, so you can check it in application servers. And the next one is quite more juicy. It's a system info call function that it can allow you to obtain some useful system information from an RFC server. There is no need also for logon data, and it's available in application servers. So you can just make this call to an application server, and you will get the kernel version, hostname, time zone, the operating system version, which database is being used. So for an attacker that wants to make some exploits or whatever, or want to use an exploit, this is quite useful information. It can be restricted anyway, but it's not really often restricted. And beyond these 3 documented functions, I realized that there were also other functions by default that they were not really documented. And the worst problem was that many of these functions contain security vulnerabilities. So the idea is that they can be called just as any regular function that you have developed. So if you develop an application using this library, you will be quite likely to suffer from these vulnerabilities. Let's make a quick review of the functions. The first one is called RFC, Trusted System Security. This one applies only to Windows systems, and it allows you to check if a user, a group exists in an external system, its domain, or its trusted domains. Okay, it just calls a native API of Windows that allows you to do that. The second one is the denial of service. Okay, if you are using a registered server and you call this function, you are going to be able to exclusively use that server. So it's like a denial of service by design. The third one is RFC start GUI, that it contains a buffer overflow, so it may allow you to perform some remote command execution. System create instance, also the same, contain buffer overflow, so maybe remote command execution. And there was one that got my attention, that was this one. It was called RFC start program, and it was receiving a parameter called simid. Okay, so I say, okay, I have just to specify which command I want to run, and it's going to be run. It was not that easy, really, because if you want to develop a program that provides access to this function, you have to use this RFC allow start program and specify which program you want to be able to execute. I mean, they really put some security on this. But okay, there was also a buffer overflow here. You are able to determine how it is used, okay, mainly because it tells you if it is being implemented or not. Okay, by default, this function is not going to be available, so you are not going to be able to just call to start any program. And there is also a path traversal attack. Okay, so if you know one command that is allowed, you can execute another one in the same drive, probably. Okay, that's the idea. I don't know how we're winning in time. Okay. This is Sapito. I don't know if any of you have heard about it. That logo is because in Spanish, Sapito is like little frog, beyond the place with SAP and Python stuff. Okay, Sapito is a public framework to perform SAP penetration tests. I really saw a lack of tools in this field, so I decided to create Sapito. It's plugin based, so you can add your own plugins and extend its functionality. It's shipped with many plugins to really analyze these RFC vulnerabilities that we're going to describe. We're going to make some live demos and to audit different kinds of SAP configuration and stuff. Okay, it's open source. It's developed in Python and C. It has some interface in C with the library of SAP, and just the link where you can get it and download it. This is some of the available plugins that Sapito has until now. You can make RFC pings, you can register the external servers, you can work with RFC exec and SAP XPG that we are going to describe now. You can get system information, you can get this server documentation. These are like more to perform the actual penetration on the system, and okay, you can run some commands, do some attacks that I'm going to describe, and you also have this the obfuscator tool to do the password stuff. I'm going to show you just a quick demo of Sapito. It is in Python, but it's only supported in Linux for the time. The ones that came to the training may know it quite good. It's run Sapito. Okay. Sapito can be run in two modes. Okay, the first one and less advisable is to run it in interactive mode, where you can, I don't know, for example, go to the plugins section and list the plugins. Okay, it's very ugly because of the size, but it's not that ugly. You can list attack plugins. Okay, so and you can configure every command. Okay, it has some tab completion and history, but it's really tough if you work in interactive mode. We're going to run it using scripts. Okay, you can specify a script that is really just which commands you want to run. It's a list of a command, one per line, so it's very handful. And I use this script just to define the targets that we're going to analyze. It's an SAP server. Okay, so here you can see really that the user and password doesn't really matter, because we're going to use functions that you don't require authentication. So we go into the plugins section and we run, for example, I don't know the time. We run a ping plugin. Here we enable it for execution. We go back and we start the session. So this is going to take a while because the SAP server is very far away. It's like in my notebook. But now it has some DNS stuff. SAP is really tricky with DNS, so the first time it takes a little, then it just runs smoothly. Okay, so there the ping plugin execution started, and the result is that the system is available. Okay, quite just a ping. Okay, not very complex. More complex or more useful plugin is the SAP info plugin. So we set it for execution and we start it. So you can get quite interesting information from the SAP system. Okay, you can get the database code, you can get the kernel release, the IP address, anyway, you're going to get that. Okay, the database that is being used, different kind of information that may be useful. Okay, so let's go on. Anyway, there is more demo later on. Okay, so now we're going to describe maybe which are the, I think, the low-hanging fruits, okay, that must really be secured, the first thing that you should secure. Quick. The first one is the RFC exec, okay. This is a program that is really an example that is delivered with the library, the RFC SDK library that you use to develop software enabled to RFC. It works in register mode, okay, so the server is going to register to the gateway and telling the gateway, okay, I'm going to use this program ID, that is most common, the program ID is RFC exec, or the hostname and RFC exec. And the idea is that it was released as an example only, okay, just to show people how to use it, but the thing is that many people use it in production really, so that's administrator, shame on administrators. But the danger here is that these three functions, you can see the names, they are quite descriptive by themselves. You can execute commands and you can make some file stuff. You can also send mails using mail command in Linux. So we're going to show it. Okay, the idea is that for this, I'm going to, first of all, I'm going to show you the check RFC exec plugin. Okay, so first we should know if RFC exec is available or not. Remember that it works in register mode. If you really have a bad administrator, that it's going to be present. Otherwise, it's not going to be present. So we set it for execution. We go back and we start the session. So this plugin, what it does is to try different program IDs that maybe I mean the most common ones, just test them and also test them using the hostname before. Okay, so here you see that this external server was not found because it's not there, it's not present. So now we are going to enable it. Okay, so now RFC exec is present. I mean, the SAP administrator is not going to do this manually. Surely SAP is going to load up and start it if it's present. So we're going to run it again. And here you can see that Zapito has found that the RFC exec was present. Okay. So now you can use an attack plugin. It's called RFC exec. RFC exec. Exec. So you enable it, you go back and start. The default command that it has, that is obviously configurable, is who am I. So it said that it was sent successfully, and you can check here that it was really sent successfully. So you are running commands. You are really running commands not on the SAP application server, you're running commands on the external server. But the problem is that many times, if it is registered, it's most probably that it's going to be registered in the same host as the application server, so you end up running commands in the application servers. Okay, that was RFC exec. I mean, SAP really knows that there are some crazy guys that are using this in proactive systems, so they have developed this RFC exec file. Okay, this is like a kind of ICL that allows you to protect you if you really are running with this a long time ago and you need just some way to protect yourself now. Okay, you can use this file provided by SAP that I make trying to patch these crazy administrators. Okay, this is quite more critical because this program SAP XPG is not released as an example. Okay, it's really used in production. This program is really used for execution of external commands and programs in SAP system. Okay, just for legitimate execution, legal execution. Okay, if you are in SAP, an SAP module wants to call an operating system commands. As an operating system command, it's going to use some default, some SAP function models that will end up running this RFC server, and that RFC server is going to be the one that really executes the operating system command. It works in started mode. Okay, you're not going to find it registered. It's just it's being started on demand, and it provides these three functions. That again, and this is not quite so descriptive, but you can just pass which command you want to execute on the application server. Okay, this is going yes to be run in the application server. So we say that we can tell. I mean, really, it's going to be run in the gateway. Okay, but really the gateway is almost always in the same host as the application server, so it's the same. Because I mean, the attack really is. Okay, we know that we can tell the gateway to run a command on a remote host. Okay, what if we tell the gateway to run this command on local host? Okay, so the gateway is going to start this program and wait for our RFC call that we're going to send him our command, and it's going to be happily run. Okay, so if we have time, we're going to make a demo of that. I should rather show you the advanced attacks first. Okay, the advanced attacks. We will be working in this scenario, okay? We will supposing that there is an application server, yes, an SAP application server, obviously, because otherwise we will not be there. But the idea is that you are pen testing a system that has external servers working in register mode, okay, that are working with this SAP application server. This is not, they are not blind attacks, okay? You need some information to perform these attacks that you can get it like network sniffing. Okay, we remember that it's the clear text by default. You can get it accessing the gateway monitor that we're going to describe now. You can also try kidnapping the SAP administrator. Maybe if you're using RFC exec, his service, but not really. We're not going to make a demo of that. Okay, the gateway monitor is, as I said before, is like an administration service for the gateway. There is a profile parameter that restricts its access. Okay, if it is 0, the monitoring is disabled. You cannot monitor the gateway. If it is 1, you can get only local access to the monitor interface. And if it's 2, it's the access is enabled by default. The access is enabled for remote access. So up to kernel 620, the default value is 2. Okay, there are many systems running with 620 versions prior to 620. So if you are an administrator, try to take that parameter and change it. And well, if you really have access to the gateway monitor, you will has all the information that you need, plus some. I mean, you can shut down the gateway. You can really do nasty stuff. So try to set it to 0 or 1 at least. Really try to set it to 0 better. Okay, so the first attack is called, I call it Evil Twin. And okay, I told you that the registration of external servers can be done remotely. Okay, you can go and tell the gateway, I want to work in register mode with you. This connection can be restricted. It's restricted through a file called reginfo that we're going to discuss next. But the problem is that by default that file doesn't exist, so you can just go and register yourself at the gateway. Okay. Until now, there are no risk in that operation only to go and register yourself. The problem is that there are two factors that made up the problem. Is that first of all, the external servers can register themselves many times with the same program ID. Okay, this was sought from SAP, like to provide some multi-threading support in a very particular way, but that was the idea. And the problem is that not only the same system can register a program with an already used ID, but any program can register itself with the already used ID. Okay. So I think we can see it graphically better. This is like a fancy diagram that a friend of mine made. I mean, you have the application server, the gateway, that's usually, remember, that's usually the same host, and an external server. This is the legal external server that is working with the application server. It registers itself with the ID reg1, okay? This is information, just all the information we need is to know the ID, the program ID, or the TP name that is being used, okay? So it registers itself. The application server at some time is going to make an RFC call to that external server, yes, just to, because it's there for that. The external server is going to process the call and going to send back the results, okay? Any further call is going to be made and it's going to be the gateway, and the gateway is going to send it to the external server. So the attack is something like this, An attacker deploys his own external server. First of all, he blocks the connection. Yes, he connects to external server, the legal one, because he knows his ID. As he tells the gateway, okay, I want to connect to reg1, so the connection is allowed. And it blocks the connection, okay? It's just making the connection not available for any other clients, okay? You can use, I mean, it can be, that function, the default function can be used, but if it's not a multi-threaded server, you just connect and it's blocked. And it is that now you register yourself. I mean, it registers itself with the same program ID. So now, when the application server makes a call and it wants to go to reg1, you are going to be the destination of the call because there is one but it's busy and the next one is you. It's like a round robin queue, so the next available is going to be serving the call. So it will be the attacker, okay? Okay, but when I develop this, I say, okay, this is nice, but I mean, you're really disrupting operations. So I mean, it's going to the regular operation is not going to be possible. So I think that you can really imagine if you take a small effort. The evolution of that attack is a man in the middle. Okay, so the same scenario: the application, the external server registers itself at the gateway. This is the legal one. Calls are forwarded to the application, to the external server, sorry. And okay, the attacker appears, he blocks the connection, he registers himself with the same ID. And now when he receives a connection, okay, from the application server, that is the tool to his server, he can log it or modify it, possibly, send it using his already established connection to the original server, get it back, log it, and possibly modify it and say it modified to the application server, okay? So it's going to be possible. It's like a kind of RFC man in the middle attack, okay, something like that. And the final advanced attack, okay, this was, I mean, when I did this, okay, I say quite nice. I mean, there was nothing like this before, but I realized that I have overlooked a really important feature of RFC design, and it's its ability to perform callbacks, okay? So what is the idea behind this is that you have an RFC client that sends an RFC call to a server, but the server at some point needs more information from its client. So it sends itself an RFC call to the client who sends results, and then the RFC server keeps on processing and sends the final results, okay? So the problem here is if this RFC client, okay, is an application server, and this is a malicious RFC server, okay? Because this happens because, okay, the problem is that the RFC callback, I mean the callback that the call that the server issues to the client hits the same context of the original call. Okay, so if a privileged user make a call that is a tour to an external server, this server is going to make a callback using the already established connection. Okay, so it's not going to need to authenticate itself. And if the user is privileged, you are going to be able to run commands, I mean run function models with that user authorizations. Okay, I mean it will be something like this. I think that you're going to have some nightmares with its flying packets, but the attacker appears, he blocks the connection again and registers itself. But this time, when the application server makes a call, and it's the tour, this is not going to forward it or just keep it. It's going to answer back with a poison RFC call. And it's going to go to application server and it's going to get read. Okay. So let's see a demo of this. No, first of all, this. The idea is that let's close this. I mean, this would represent the original server. Okay, this is the original, the legal server working with the SAP application server. It's registered with reg1. So now SAP in any moment is going to make a call like this one. Okay, I don't know if it's in okay, but it says call function, the function name, and destination reg1. Okay, so this function is going to end in the original server. I'm going to show you. I mean, I'm executing the function, so forget about the errors because I stink programming in ABAP. But okay, here you see that it received a call. I'm going to execute it again, just for you to see that I'm not lying. Okay, 2 calls, and they're all sent to the original server. Okay, so now we are going to show this callback attack. We need Sapito again. So first of all, remember that what we need to do is to block the connection to the original client, the original server. So we're going to use a script. This time we're specifying that the connection is to an external server, okay, not to a gateway or an application server, and that external server has the ID reg1. Okay. So we go to the plugins. We use the stick plugin. Go back. Start it. I think this is also going to take a little bit, but the idea now is that we are connecting to original client to make him block the connections from other clients. Okay, so now we can receive a call that is made to his program ID. So this is a stick plugin. It's like a little shell plugin. Here you should connect. Okay, so now you can see that it's a stick to a remote server. Okay, so it's blocking connections. So now what you need to do is to run another Sapito like this. Sapito. We're going to use another script. It's called off-the-shelf. So, okay, this time we're going to connect to application server. That is, I mean, really the gateway. See that there is no user and password involved here for anything. We're going to use a plugin that is called RFC-Shell. We set the program ID to reg1. Okay, so we are going to register ourselves with the same program ID. We set it for execution with the attack, and we start. Okay. Then in the RFC-Shell we have to use also a start. And now we are in the state where we are registering. We have registered ourselves, okay, with that program ID, and we are waiting for the call of the application server. And because we have blocked the connection to our client. So now the application server is going to issue this call that was originally served by this server, but now hopefully I have issued the call. Yes, you can see here that I'm going to set it a little up. Can everyone see that? I'm sure. Here, the call was received. Okay, our official Sapito server will receive the call. So here you can just you can just dir directories. You can just read files. You can also read some more interesting files like C's profile. You can read SAP profiles. Okay, you are running, and you can also do something like this. Okay, that check it. Okay, whatever. So you are running commands using this kind of weird callback attack. That's the idea. Okay. Well, they are all not bad news. I mean, there are ways to protect, if you're an administrator, to protect against it. It's important that, I mean, it's not like it's an SAP problem. I mean, maybe the patch and the vulnerabilities in the library, they're development problems. But this one is configuration problems. Okay, it's responsibility of the administrator because he already has the measures in place to protect against this attack. The problem is that by default, I mean, this is possible because this configuration is not implemented and it allows like everything to go. You have to protect against started servers. You're going to use a file that is controlled through this parameter profile. where you're going to specify which user can issue a remote command to start a remote server. And the most important thing here is that you can control from which host he can start a remote server, where he can start it, I mean, in which host it is needed to be run, and with which program ID. Okay, so this is a whitelist ICL file. So you really have to restrict only which stuff you want to be able to I mean, that you really need in your SAP system. And to protect against this callback attacks, registration of external servers, this parameter reginfo, where you have to specify which program ID. I mean, when a new external server wants to register itself, it's going to check his program ID, okay, with this TP parameter here. From which host is it being registered, so you can just limit that they register from only known host that you know that you use. This will prevent the evil twin attacks. Here you can restrict with the number parameter. You can restrict how many clients, how many servers can use the same program ID. And you can also restrict who can access it and who can cancel it. Okay, so the measures are in place. It's just default wrong configurations or laziness of administrators. So make sure that your administrators are really aware of this. Some conclusions. Okay, we have seen that the RFC interface is quite a wide door into SAP systems, and it has to be locked. I got really nice feedback from SAP when I started reporting this bug. They respond quite quickly and in a very professional way, I think. So they developed this node that you can download and protect your system. Enforce your SAP administrator to apply these patches. Remember that the RFC is clear text, so you have to enable SNC if you want to protect this information. Remember that it's sensitive information usually, so you should implement SNC. And as a final conclusion, these attacks and caveats that we have described, most of them can be avoided if you really use a nice configuration and you apply patches. Okay, please don't forget about this secinfo and reginfo files, because by default all these attacks that I have shown you are possible. Okay, in every SAP system, because the last version, that is 7, I think, it's also by default available. Okay, so any questions? Anything that was not clear enough? Anything about P2, whatever? There we have one.
Well,
I know. No questions?
Well, you can maybe should take a break, but you're available at MetaLab tonight?
Yes.
So if you want to set up your very own personal SAP botnet, please contact Anino later on tonight. Thank you very much for listening.
Okay. Thank you.